just know that I'm gonna like up it every class a little bit. Okay, so this is just to make sure you're okay. All right. So the first one here, you can tell that you have a pair. So I'm going to start with that sine of 42 degrees over 17 meters. So I need that set up, okay? So then I will have sine of x over 22 meters, right? I would say I would give you a mark for that, for the correct setup like that, definitely. And furthermore, down the road, you identifying sine law as the one that has to be used is also going to be a value, okay? So then you cross multiply and divide. So sine of x, and this is where notation is going to be a problem for some of you today. So I want to see, right, that you cross multiply and divide like that. Right? And you might, I don't know, I'm thinking I'm going to cut it off here. So I'm actually going to just use an extra line here. Sine of x is, and I figured that out. I don't have it on my key here, so I like to see that. So that's 0.8659, and it keeps going. So angle x is going to be sine inverse like this of 0.8659 dot dot dot. Right? So sine inverse of my answer is going to be 59.99, not 60. Rounded to 2 decimals, it's that. So normally I'd ask you to put the decimal right next to it just to save space. I used an extra line, but I want to see this part here before you state your final answer. Okay. So what did I say? 2 marks each. So obviously if you get the correct final answer and the notation is right, you get 2 marks there. Next, you have your pair here. But, right, we're going to figure out that we might have to do a little bit of extra work. Because if you want to find this side, you need this angle, and that should not be a problem, right? So I'm going to do that up here, right? Just 180 minus 35 minus 88, and that is 57, right? So normally I'd give you an extra mark for it, but today, to keep things simple, 57. So it's sine of 57 over side x like that. Cross multiply and divide. Sine of 57 like that, divided by sine of 88. So that gives you 36.92. Sorry. 36.92 millimeters. So 1 mark for the setup, and then 1 mark for the correct final answer, including units and all of that. You know the drill. And this one here, actually, I'm looking at it. There's a problem with it, but you won't find out until way later. That's okay. All right. So here I have my pair. So I'm going to start with that. Sine of 51 over 9.4 centimeters. And I'm going to go sine of x over 6 centimeters, like that. So sine of x is 6 times sine of 51 divided by 9.4. I'm going to have to use an extra line, 0. I did not write that down, so let me see here. 0.4960, it keeps going. So angle x is going to be sine inverse of 0.4960 dot dot dot. Angle x is 29.74 degrees. So again, 1 mark for setup, 1 mark for solving and getting the right answer. Should have given you more room. it is what it is, right? So next, solve the triangle. So when you solve the triangle, right, again, you start the same way. So let me just go through the process here. In this case, you want to solve for side B first, right? That, well, it would be easiest. So 9.8 like this, sine of 51, you're solving for side B, just make sure you know that. That's 9.8 times sine of 51 and sine of 71. So if you're just looking, it's like, yeah, I know what it's going to be, right? Then you're in pretty good shape. So B is 8.05. And we are in centimeters, right? So I give you 1 mark for setup, 1 mark for the correct answer. And right next to it, I'm going to start with the same pair that I had to begin with. But I'm going to find sine of C. I'm going to find that angle because I want side C to be solved next. So 180 minus 51 minus 71, that is 58. 58 degrees. Let's give you a mark for that because it's technically, that's angle C, right? Angle C. So whenever you can assign a letter to it. So we have sine of 58, cross multiply and divide. 9.8 times sine of 58 divided by sine of 71. And my answer says 8.79 centimeters. Hold on, is that right? Yeah, okay. Centimeters, we're good. So that's 1 and that's 1. So 1, 2, 3, 4, 5. Because now I have all 3 sides and all 3 angles. Okay. Right, they have to give you 3 pieces of information before you can start. The only triangle, remember this, I'll test you to see how good you're listening. The only triangle that cannot be solved is one that has only 3 angles given. So let's say they give you all 3 angles. There's nothing you can do. You need at least one side. Okay. So that's that. So what are we at? 5 and 6. So that's 11, right? We're out of 11. So just mark out of 11. The backside was not needed today. So just put your name and last name in there, and then we'll continue with our notes on page 7. Is it 7? Yeah, 7. The height of the triangle. That one is a very nice trick. Calculating the height of a triangle. It will save you a lot of grief, and it will be very, very handy. Pass it forward, okay? Make sure your name and last name is on there. Yeah. I just didn't pick it up. Okay. I will, yeah, I'll just leave it one big video. Who's watching? Anyways, there you go. Calculating the height of a triangle. What do we need the height for? Well, sometimes a question will straight up tell you like how high up the tree is that eagle, or uh, calculate the area of the triangle. For area, you need height, right? I never put that anywhere because I'm assuming you know that by heart, but the area of a triangle is base times height divided by 2. I hope you know that, because if I asked you for area, I'm expecting you to know that. That's like, right? Other than length times width, that's the next one your elementary teachers and junior high teachers probably try to drill in. So I will say height of a triangle. And remember that the height is always measured perpendicular to the base. Okay? So wherever you see a straight line and the height meeting it, right, that it should be a 90-degree there. So it could be depth, like if you're looking for the depth of a treasure underneath the surface, right? That would be depth, but it's still the height of the triangle if you think about it. It's just flipped upside down. Okay? So watch this. Hopefully this will make sense to you in this case. Okay? So let's cut this in half. I want you to understand why it works, not just here is the formula, take it, right? That I try to stay away from that. So let's cut this into 2 triangles. So if we take the first one out, and let's make a little sketch here. This is the height of the triangle, which is unknown to us. This corner right here we know is 59.8. It's all from the original, right? We know that this is 4.52. Let me zoom into that because I will first work with that side. So there we go, that's better. So I'm just copying things over that I know are there. Just to make sure, I put that 8.2 feet here on purpose. For some reason, when students see a line touching another one, they cut this in half, boom, they bring it with them. No, it's only if it's an isosceles or an equilateral triangle. Other than that, you assume that you're not cutting it in half, okay? That's very important. So I'm ignoring that 8.2, I'm not bringing it with me. But watch this, you do have a pair here. That box represents how many degrees? 90, right? So you can go sine of 90 over 4.52, okay, is equal to this angle, the 59.8, is across this height here. You see that? Sine of 59.8 over my height. So let's cross multiply and divide that. 4.52 times sine of 59.8 divided by sine of 90. Before you do this, try sine of 90. What do you get on your calculator? You'll never forget. You only have to do it once. If you press sine and then 90, it's 1. It's always 1. So it's almost like you can replace sine of 90 with 1 if you'd like to. So basically, when you go 4.52 times sine of 59.8, there's no need to divide it by sine of 90 because that's really just 1. But I still put it in there to keep the system the same. So that is 3.91, right? 3.91 is my height. And we are in feet. So that is important to me. I'm going to box that in. Okay. I just figured out that the height is 3.91. And you have to agree with me, right? Once you find the height, it doesn't change, right? It should be 3.91 regardless of what you do. So let's try the same thing with the other side. Okay, I'm going to take that second one out, this one, and let's draw that. I know it's a little blurry. I'll refocus here. And let's see what we have. We have the 33.4. We have the 7.1. We have that this is a 90 as well. And this is my height here. This is the unknown. And now I'm going to zoom into that side. I hope this works out. I hope there were no typos, okay? This is sine of 90 over 7.1 is equal to sine of 33.4, this angle right here, over the height. And after this, I'm going to give you a formula that it works every single time. Sine of 33.4 divided by sine of 90. It better be 3.91, right? Or else we have a problem. Yes, it does work out. I got 3.908, which turns out to be 3.91 feet. Right, so then we can zoom out. As you allergic to math. Anyways, so you can see, right, regardless of which triangle you use, the height stays the same. The height stays the same, which is not surprising. I know it's not surprising to you. If you have a different highlighter, or maybe just the highlighter you've been using all along, I don't know. I like this to really stick out, right? That we're finding the same height, right? We just use different approaches, right? We use the left side or right side, but the height remained the same regardless of what we did. Okay? Yeah. One side, and I'll show you. It's going to be even sweeter than this. It's going to be a lot quicker. Yeah. But let me pause here for 1 second. Press pause. Okay, Mr. Dirksen. So you're saying the 59.8 is across this length right here, right? But let's go back to the original and just focus on the big triangle here. Notice that the 59.8 is also across which side? 7.1. So you can use it interchangeably. You just have to be very careful, right? You can't use the big triangle dimensions and then mix it up with the right triangle. You can't do that, right? So you gotta kind of be consistent. Okay. So let's go over the general formula. And here it is. This should be, it's boxed in, right? I told you what that means. Did I ever tell you what that meant? Study sheet. Yeah, if it's boxed in, study sheet, right? That's basically in a nutshell what you should remember. And what does this mean here? Height is equal to side length times adjacent angle. Touching side, right? It's the side length times the angle that's touching that side you're interested in. So for example, PQR is my triangle. So this would be side R. Angle P here, this would be side P. Let's just focus on those two. Label them. So the height in this case would be what? If we go from the left here, it would be side R times this angle right here. This angle right here. So sine of P. Or the height could also be found by coming from the other side, which is P, side P times, you've seen times as a dot, right? I hope so. You can go times if you'd like, or brackets. Times, it's this side is touching this angle, so sine of R. So there's two ways of finding the height, I guess, using this triangle. And I guess it goes without saying that you wouldn't be using the angle that connects these two sides, right? It's like the base and the height. You identify the base and the height, right? So it's going to be one of these two angles that you're going to be using, right? It depends on how much information you're given. And so in this particular case, this would be the base right here. This would be the base for this triangle. Okay. So let's label this triangle. If this is capital E, then this would be lowercase e, capital D, lowercase d. So if you want to find the depth of something, you would say depth is E times sine of D, angle D. That looks like an L, doesn't it? It certainly does. So I will change that there. So E, this side, times sine of D, that angle. Or depth is D times sine of E. Alternatively, you can do what I just did up there, which takes more time, in my opinion. And what about this one? This is the triangle, and if you wanted to find the height of this triangle, the height is outside, right? Height is outside triangle, okay? It happens. It does happen with an obtuse triangle. That's going to be the case, but you still approach it the same way. This is R here, and this is side P. So to find the height here, you would go R times sine of P, or height is P out here, side P that is, times sine of R. And trust me, I will ask you for this quite often, so you'll be pretty good at it after a while. I think I just wanted you to see different instances where this is going to be used. In chapter 4, you're going to have to find the height a lot and quick, right? So that's why I wanted to introduce this already, so that we know how to handle it. I hope this makes sense. So I showed you why that works, because if you think about it, sorry, you're still copying. We went 4.52 times sine of 59.8, right? We took this side and we multiplied by sine of this, right? Same with the other side. So make sure this is down before I move on. We'll do a word, it's already a word problem actually, yeah. And then I will already start cosine law today. All right. So we're gonna go to page 9. Okay, page 9. Kat and Steve are hiking in Oogaboo Provincial Park in BC. Anybody been there? Grace, you have? All right. I've never been there. So, sounds like a made-up name, but I guess it is an actual thing. Provincial Park in the Silver Basin Meadow. They follow a creek. They are 20 meters apart. On one side of the creek, they spot a pika, which is a small mammal. On the opposite side of the creek. You recognize that, right? So this is, in this case, I give you a diagram, so I don't really call this a word problem yet, because the diagram is provided and it's filled in with all the information you need. So calculate the distance from each hiker to the pika, right? So we're going to calculate the distances. So when there are no variables given, folks, do that yourself. We can call this x and this y. So we're going to go ahead and do that. So this is something where I mix up. Be very careful. I'm going to mix up the right triangle that is inside. There's actually two, and the big triangle on the outside. So we're going to Kat 2 pica. We're going to do that first. And so what I'm going to do here is figure out, you need to know that there are 2 angles and the side that connects them. So I can easily find this third angle up here. Okay, let's figure that out. Angle P, I'm going to call that angle P, is 180 minus 17 minus 36. I told you that in your notes. When you have 2 angles, find the third one. There's a chance you're going to need it anyways. Okay, so 180 minus 17 minus 36, that's 127 degrees. Okay, that's important to me. So I have the 127 spans across from side to side. Okay, so I'm going to go sine of 127 over 20 meters. Because remember, watch up on the diagram. If the angle goes from end to end, I can use that whole side down here. Okay, so you got to be able to look past the cuttings, right? The lines that are in there. Next, if I want cat to pica, which one do I need to use? Which angle? I need to use the 36. Okay, sine of 36 over x, and I'm going to cross multiply and divide. 20 times sine of 36 divided by sine of 127. And I get 14.72, and we are in meters. So that would be the distance from cat to pica. So always make sure to add variables into the diagram if they're not provided. Okay. We are now going to figure out the distance between Steve and pica. I'm going to start with the same pair that I had before. But in this case, I'm going to use the angle 17, which is going to give me the side that I'm after. So that's 20 times sine of 117. Sorry, not 117, just sine of 17. And if there's always a few that want to like shortcut this and just go right to the answer, don't do it. It's going to cost you if you get it wrong. So just show the steps. It takes a little longer. I flipped it. Oh, no. I want the 17 degree here because that's going to give me the side across from it. So we're good. Yeah. So I got to divide by sine of 127. That's 7.32 meters. And it makes sense. It's a smaller angle across from it, so it makes sense that it's shorter, right? And the diagram would confirm that as well. Make sure your calculator is set to degrees. Okay. So we've got that figured out. Okay, good. This shouldn't be new to you. This should be very doable. But the next part is where we apply what we just learned. How wide is the creek? And how do you find the height of a triangle? That's basically what, right? If you want the width of the creek, right, how wide it is, you're essentially finding the height of the triangle. So you have a choice. You want to go x times sine of 17 or y times sine of 36. It's up to you. Okay, so height is going to be x times sine of 17, or it's going to be y times sine of 36. It's up to you how you want to do it. If you're using x, then it's 1472 times sine of 17. And if we did it right, we should get very close to the same answer. This is 4.30 meters. Or we have 7.32 times sine of 36 on the other side. I don't know why I'm still checking, but I guess I want to make sure that it does indeed work out. Okay, so 4.30 meters. Okay, so this is the width of creek, right? I'm making sure you understand that it's the height if you were to stand it up, but if you lay it down flat on the landscape, right, it's how wide the creek is. Okay. All right. Intro to cosine